Hello, everyone. We are going to start today chapter 7, and the first section is trigonometric identities. Let's start with understanding what is the difference between identity and equation. For example, I have on my top line sine of x equals to 1. This is called equation. Why? Because there is a certain solution for this equation. For example, x equals 0 is not going to work here. Sine of 0 is equal to 0. But x equals pi over 2, 90 degrees, is going to work here because sine of pi over 2 is equal to 1. So equation usually has a solution. Solution is a one number or set of numbers which is going to turn equation into a true statement. By itself, it's not a true statement, but if you find a certain number which solves it, it's going to become a true statement. So sine of pi over 2, for example, equals to 1, and that's a true statement. What is identity in comparison to equation? For example, I'm going to work with Pythagorean identity, sine square of x plus cosine square of x equals to 1. Well, for which x this identity is true? Actually, for any real number, right? You plug in any real number here. You can plug in 0, you can plug in pi over 2, pi over 4, 2 pi, whatever you want. It's still going to be true. So identity is going to work for all real numbers here. So in this section, we are going to learn how to prove identities. So how to prove that a certain statement is going to be true for all numbers, not only for like a certain number. Let's start with basic identities we already know. So in the book, they call them fundamental trigonometric identities. So I'm going to label fundamental trigonometric identities. Well, we are going to start with our first identities we learned when we started working with trigonometric functions, right? We remember that, for example, tangent of x is what? Sine of x or cosine of x, right? And the secant of x is 1 over cosine of x. And the cosecant of x is 1 over sine of x, right? These are good identities, and usually we don't prove them because we define actually tangent, secant, and cosecant as like for example, if we define cosine of theta as x, we define secant of theta as 1 over x. So we kind of proved it when we were doing definitions, right? What else? I'm missing cotangent. Let me write down cotangent. Cotangent of x equals cosine of x or sine of x, right? We remember that we have functions like tangent, cotangent, and cofunctions. Like it was like tangent and cotangent are cofunctions, right? Also, secant and cosecant are cofunctions. We are going to learn a little bit later why are they cofunctions, so what complementary to what they are. Well, we already did Pythagorean identity. We review Pythagorean identity. There is one more Pythagorean identity which is looking like slightly different from this one, still called Pythagorean identity. So I'm going to maybe kind of label that as Pythagorean identity. And there are several of them, right? We're going to start with our familiar one, sine square of x plus cosine square of x equals 1. And remember, for unit circle, it was like actually x squared plus y squared equals 1, right, for unit circle. And it was equation of a circle, right? But because we defined x as cosine and y as sine, it turned into Pythagorean identity. Now, what I'm going to do, guys, I'm going to divide this Pythagorean identity by cosine of x. So I'm going to have sine square of x over cosine square of x plus cosine square of x over cosine square of x equals 1 over cosine square of x. As you probably see, cosine over cosine equals to 1, right? What is 1 over cosine? Let's look up. 1 over cosine is secant. Because it's squared, it's going to be what? Secant squared of x. What is sine over cosine? Again, back to fundamental identities. That's a tangent, right? My square does not look very like nice here. Maybe I should a little bit like erase it and write it down normally. Otherwise, or I erase it actually. Okay, that's a square. So this one is what? It's tangent, but because everything is squared here, we are going to have tangent square. And we are getting a new Pythagorean identity, which is going to look like this. Tangent square of x plus 1 equals secant square of x. One more identity you can get if you divide this Pythagorean identity not by cosine, but by sine, right? If we divide this part by sine, we're going to have sine over sine, which is going to give us 1, right? Plus, I'm not going to actually write it down. I'm just going to talk about this. If we divide cosine over sine square, we are going to get what? Cotangent square. Cotangent square. And 1 over sine square, which is going to be 1 over sine cosecant, is going to give us cosecant square of x. Most of all, you are going to see this too. This one, I almost never see it used. What other important formulas we'll need to kind of recall? Well, we have even and odd identities. We do remember that even, odd. We do remember that sine of negative x equals negative sine of x, right? Because it's what? It's odd function. Odd function, let the minus go outside. For cosine, because it's even function, it's just going to get rid of the minus and, sorry, accidentally started writing sine, and just become a cosine back. Cosine of x, right? Well, with tangent is going to be what? Because tangent is sine over cosine. When we put minus in front of x here, sine is going to allow minus go out. Cosine is going to just consume the minus. So we are going to have minus in front. I'm going to write down that tangent of minus x equals minus tangent of x. So tangent is also odd function. You probably remember the graph, which was looking like this, right? Odd function are symmetrical about origin. Okay, so well, I don't really think that you are going to use cofunction identities, but let's kind of write down a couple of them. Cofunction identities. So I'm going to write down that's a sine of, well, actually, maybe we should not do cofunctions because we did not cover yet chapter 6. Okay, let's leave cofunction identities until we cover actually chapter 6, and that's what are cofunctions. Okay, now let's just talk a little bit of how people are proving identities. I'm just going to show you several examples of proving identities, and I want to change my color, maybe make it blue. And, you know, I want to draw a little bit thicker. Well, I don't have much actual option. If I choose this, is it going to be nice? Okay, I'm going to start with example. Oh no, that's too thick actually. I don't want to draw like this. So let me erase this and go back to my normal. So we're going to start with example number 1. Example number 1, I'm going to write down identity to prove. So usually you are going to see it in the book. Cosecant of theta, sorry, let me just rewrite it normally. Just my theta doesn't look like theta. Cosecant of theta multiplied by tangent of theta equals secant of theta. Usually the question is it a true or false identity? Is it a real identity, or actually it's not an identity, it's just a mistake? Well, guys, you see that identity usually going to have two sides, left side and the right side, right? So I'm going to label this one is a left side and this one is a right side. when you prove that identity is true, you wish actually write down something like 1 equals to 1 or cosine of theta equals cosine of theta, which is actually obviously going to be true, right? So normally to get to this point, you either develop left side of your identity or right side of your identity or both sides. For this example, I'm going to develop left side of my identity. What I'm going to do, guys, I'm going to represent cosecant and tangent through the sine and cosine, okay? And then if I can get to secant, I'm going to be happy. If I cannot, well, I'm going to tell that the identity is false. So remember, what is cosecant? Cosecant is 1 over sine of theta, right? What is tangent? Tangent is sine of theta over cosine of theta. I'm going to write down that here I'm working on the left side of my identity. Well, what is, if I am working on one side of my identity, I can write down long statement. If I'm working on both sides of identity, I'm going to write them down one underneath of each other, and only one equal sign is going to be written. So left side, I see that sine here and sine here can be canceled, and I have 1 over cosine of theta. We remember that just from review that 1 over cosine of theta is a secant of theta. So we see that our left side simplified is going to be exactly equal to our right side. So you can write down right side. And if left side is equal to the right side, left side is secant and the right side is secant, you can write down that identity is true. Okay. Next one. Example number 2. More complicated one. Oh, sorry, my hand leaves some marks on the whiteboard. So example number 2, more complicated. 1 plus tangent of theta divided over 1 plus cotangent of theta equals tangent of theta. Well, more complicated, right? The question is again, true or false? Is it working identity or no? Well, again, I'm going to work with my left side. Left side, I'm going to simplify it by using identities for tangent and cotangent. So tangent, we remember that's a sine of theta over cosine of theta, right? And cotangent is cosine of theta over sine of theta. Now I'm going to bring my numerator to common denominator and my denominator to common denominator. You see that I have a complex fraction here. So common denominator is cosine here. So I'm going to multiply by cosine theta. Cosine of theta is this one. So it's cosine of theta plus sine of theta divided over cosine of theta. This side, denominator, common denominator is sine. So I'm going to multiply actually 1 here by sine and then kind of divide by sine. So get common denominator, sine of theta. Well, now guys, I have a complex fraction. We can, if you see that you can cancel numerators of both fractions, top and the bottom, you can do it. If you don't see it, I'm going to kind of continue explaining how to simplify this fraction. We remember that division or fraction bar, it's division. Division is multiplication by inverse fraction. So I'm going to write down the top as my original fraction, right? And the bottom, I'm going to flip it over. Put instead of division, multiplication, and write it down as a sine of theta over, well, I'm going to write down, let me actually keep the order. Otherwise, it's going to be a little bit confusing. I'm going to write down what we have, sine of theta in denominator plus cosine of theta, right? You see that the numerator here and part of denominator here are like factors, and they can be canceled because they're exactly the same. Cosine plus sine, sine plus cosine. And what is left over is a sine of theta in numerator and cosine of theta in denominator. Recall that sine over cosine is what? Tangent of theta. And tangent of theta is exactly my right side, right? So I proved my identity, true. So that's it. I proved my identity. Well, I think here again, I was developing left side, but this is not only one method to do it. You can use different methods. I'm going to change my color and consider example number 3. Example number 3, identity 1 minus sine of theta divided over cosine of theta equals cosine of theta 1 plus sine of theta. Here, guys, I'm going to keep identity and I'm going to modify both left and right side of identity simultaneously. What I can do with identity? Well, everything what I can do with equation. For example, I can multiply both left and right side by 2, for example, or divide by 2, or multiply by sine, or divide by cosine. The only thing I cannot do is multiply by 0 or divide by 0. Everything else is kind of possible. So what I'm going to do, guys, I'm going to multiply my identity. Let me change the color to show you like the difference. I'm going to multiply by denominator of my first fraction by cosine of theta. Cosine of theta here and cosine of theta here. Why? Well, I want to actually cancel cosine, so it cancel denominator here. Here is not going to cancel anything. But if I multiply by denominator of this fraction both sides, 1 plus sine of theta. And here, well, I don't have any space left, but I'm going to maybe write it down here, 1 plus sine of theta. I'm going to see that this denominator is going to cancel with this factor. And what I'm going to have, 1 minus sine of theta, this parenthesis, right, multiplied by 1 plus sine of theta equals, here I have cosine, and one more cosine is going to give me cosine square of theta. What I see on my left side is a formula from algebra. You probably remember a minus b, a plus b, difference of two terms and the sum of the same terms, which results into a difference of squares. Formula from algebra. I'm going to use this formula. So it's a square of 1, which is 1, right? Minus, according to the formula, square of sine, minus sine square of theta equals cosine square of theta. What I'm going to do next, I'm going to move this sine to the right side. Basically, guys, when I do this, I actually what? I actually add sine square of theta here and sine square of theta here, talking about similar operations on both sides of the identity. Sorry, I'm just trying to check if I did not turn anything off. So here, sine is going to cancel, right? And I'm going to have 1. What I'm going to have over here, it's a cosine square of theta plus sine square of theta. Well, we do know that it's true identity because it's a Pythagorean identity. So we know it's true, and we proved our identity. Okay. I want to consider 2 more examples, and I think that's going to be enough for this section. You just practice with the homework, and you're always welcome to do more problems than I assign in the homework. Homework is necessary minimum to kind of finish for this section, but you can always wander around like the similar problems. So let me consider 2 more identities. And what I'm going to do, guys, I'm going to ask you to solve these 2 identities on your own. And you can stop my video and try to do it on your own, and then turn the video back on and see my solution and compare it to yours. That's like a self-solving, right? Okay, I'm going to write down self A. 1 minus sine square of theta divided over 1 plus cosine of theta equals cosine of theta. And B, 1 minus cotangent square of theta, 1 plus cotangent square of theta. Sorry, started writing down equal sign too early. Plus 2 cosine square of theta equals to 1. 2 identities, and you can spend like 5 minutes on the first identity, 5 minutes on the second identity. If you totally don't know what to do, wait until I solve it. By the way, I wrote cosine here. I wanted to write down cotangent. Why did I write cosine? That's supposed to be t actually. Well, let me just finish it, write it down correct way. Plus cotangent square of theta. I think I was looking at cosine and writing down cosine here. So fraction is cotangents, and the cosine happens after. Okay, I'm going to stop my video for a second and then restart it, and you can stop it at this point, okay? Okay, I'm going to start solving identities. I'm going to change my color. You see that it's actually a solution, right? So I'm going to start with problem A. For problem A, I'm going to copy the problem one more time. I'm going to start working with my left side. Maybe I should write down that left side, right? And that's 1. Instead of sine square, I'm going to write down 1 minus cosine square of theta. What I'm using here is Pythagorean identity. Pythagorean identity tells me that sine square of theta plus cosine square of theta equals 1, from where I can tell that sine square of theta equals 1 minus cosine square of theta. So I'm using this fact, and instead of sine square, I write down 1 minus cosine. 1 plus cosine of theta. In denominator, I just copy it. What I'm going to do next, I'm still working with my left side. 1 minus cosine square of theta, I'm going to use the formula. 1, not 1, let's write it on like a square minus b square. I just reviewed this formula 2 minutes ago, right? Equals a minus b, and a plus b, difference of squares, right? So here I'm going to write down 1 minus cosine of theta, right? That's my a is 1 and b is cosine. And 1 plus cosine of theta divided over 1 plus cosine of theta. Now I see that I can actually cancel one factor of numerator and total denominator. And my left side is going to be equal 1 minus cosine of theta. You see, if you don't keep parentheses, you are going to miss the fact that this minus belongs not only to 1, but also to cosine. And now I'm going to open parentheses and have 1 minus 1 plus cosine of theta, because this minus is distributed towards this minus, and that's going to give us plus, right? 1 and 1 are canceling each other, and we are going to get just cosine of theta. Isn't it my right side? Yes, my right side is actually equals to cosine of theta, right side, so it's true. And I proved my identity. Just one line, right? Very long line. My next identity is B, more complicated one. Well, here again, I'm going to work with left side. It's not always going to be left side, but for this one, it's going to be hard for me to get from 1 this complicated expression. It's going to be much easier for me to take complicated expression and simplify it to 1. But again, both ways are possible. If you see that you can just multiply your identity by something and get it like obviously true, then do this. For the left side, I'm going to use formulas for cotangent, which is like cotangent equals to what? Cotangent of theta equals cosine of theta over sine of theta. Okay, so what I'm going to have here is 1 minus cosine of theta, sine of theta here, squared, and 1 plus cosine of theta, sine of theta squared, plus 2 cosine square of theta. I'm still going to work with my left side, but because I have this kind of explanation over here sitting, I don't want to continue over here. I'm going to just continue lower, okay? If you don't mind. So what is going to happen next? Well, I'm going to, again, maybe like square both cosine and sine to simplify it a little bit. So it's 1 minus cosine square of theta over sine square of theta. In denominator, 1 plus cosine square of theta over sine square of theta. Now I'm going to bring numerator and denominator to common denominator. Right here, it's a sine square of theta. So it's a sine square of theta minus cosine square of theta divided over sine square of theta. I multiplied this 1 by sine square of theta and divided it by sine square of theta. Here we have same denominator, so I'm going to do same operation. Sine square of theta multiplication, sine square of theta division. So we are not changing 1 into a different number, right? So I'm going to have sine square of theta plus cosine square of theta divided over sine square of theta. Now I'm going to put multiplication instead of this fraction bar. This fraction bar is going to become multiplication. So I'm going to copy my fractions in multiplied form. If you do see how to simplify it without multiplication, you're always welcome to do this. But because it's a lecture, I want to explain this as much as possible. So I'm flipping this fraction and writing it out as sine square, denominator up, and the sine square of theta minus plus cosine square of theta. What I see, that I can cancel factor sine square of theta. What else? Guys, when I was copying everything, I forgot about this 2 cosine of theta. And I actually don't know how to put it back, because if I start squeezing it, it's going to be looking really like squeeze. So I'm going to put it over here, plus 2 cosine of theta. I was so kind of and consumed by dealing with a fraction, 2 cosine square of theta. Well, still, we still have 2 cosine square of theta. We did not modify it. We just copied this one here, here, and here. Let me go back to my purple color and continue. So what I have in denominator, remember Pythagorean identity, that sine square of theta plus cosine square of theta equals to 1. So basically what I have sine square of theta, I'm coming my numerator, minus cosine square of theta plus 2 cosine square of theta. Well, I see that kind of minus cosine and plus 2 cosine, it's like minus 1 apple plus 2 apples, 1 apple left, right? And I have sine square of theta plus cosine square of theta. So if I combine these two expressions, I'm going to just get cosine square of theta. It's 2 minus 1, right? And I do remember that cosine plus sine is equal to 1, again by Pythagorean identity. And if I look at my right side of identity, this is my right side, right? I'm going to see that, yeah, it's supposed to be equal to 1 if identity is true. So I got left side exactly equal to the right side. And again, my identity is true. Okay, so I proved several identities. Does it mean that all identities are going to be true? No, guys, some identities are not going to be true just because they are not identities. In the book, sometimes they're going to ask you to verify identity. Verify means that just show whether identity is true or not true, find it out. Obviously, guys, how do we find that identity is not true? Well, you have something at the end, you have a statement which says something like 2 equals 5, for example. You understand that 2 is never equal to 5. Or you have actually sine equals cosine. This is not identity. Sine equals cosine happens for a certain angle of x, right? It happens for pi over 4, but it's not true for all x. You see, if you get something like this, means that identity is not true. Most of identities in the book are true identities, but just be aware that identity is not necessarily supposed to be true. You have to verify it first. Okay, that's all for section 7.1, and kind of do the homework, okay?